Okay, welcome. This is the last of the SAT worksheets. It's SAT worksheet 216 probability charts. Um, a big emphasis of the SAT when they switched formats in 2016 to the current format is data literacy or data fluency. What does that mean? So it's not so much your ability to necessarily do traditional math, like algebra and arithmetic. It's more your ability to read a question carefully, determine exactly what a question wants from you, and to be able to kind of extricate that or remove that information from a chart. So it's your ability to understand a question and then process that information from a chart. Sometimes it will just be a chart with numbers. Other times it may be a histogram or a bar graph. But what we'll do is we'll look into 3 different problems from past tests to see exactly what this looks like. So first off, you're probably already familiar with this, but probability is the outcome you want over all those that you're choosing from. So if I want an ice cream cone and I'm choosing from 100 desserts and 5 of them are ice cream cones, my probability of getting an ice cream cone is 5 out of 100 or 5%, right? This is the cone. That's what I want, and I'm choosing from all desserts. Desserts all. So that's probability. Now let's see the way this appears on the SAT. So here's a past problem here. Sorry, I know it's a little bit of an eye test. So if we look at this chart, we see that we have group X and group Y. In group X, we have 15 who recall no dreams. Dreams recalled during 1 week. 28 recall 1 to 4 dreams. 57 recall 5 or more dreams. And there's 100 people in group X. There's 100 people in group Y. There's a breakdown of how many dreams they recalled. And in the bottom, we total each category. So group X and Y, how many recalled 0 dreams, how many recalled 1 to 4, 5 or more, and then the total. Okay, so let's read and figure out what this problem wants from us from the chart. So the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtime. So group X is early bedtimes. Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least 1 dream, what is the probability that the person belonged to group Y? Okay, so that last bit is what's really important, and that's probably why I starred that in the past. Anyway, we are choosing a person at random from those who recalled 1 or more dreams. So if we look at the table, 1 to 4 is 1 or more dreams, 5 or more is 1 or more dreams. The total of those who recalled 1 to 4 dreams in both group X and Y is 39. So we have 39 that in total who recalled 1 to 4 dreams, 125 across both groups who recalled 5 or more dreams. So that's what we're choosing from, all of those who recalled 1 or more dreams across both groups. What we want, though, is only 1 plus dream, so 1 or more dreams from group Y. So on the top, we're going to have 11 plus 68, because those are the 2 points we care about from group Y. So really what we get is 79 over 164. Again, not a lot of math involved, more your ability to read carefully and to be able to pull that information from the chart. So let's look at 2 more problems. And this will be probably the quickest of all the videos because we do that and then we just do these 2 problems. And then I think you'll be good to try this worksheet. Okay. So we have course registration at a university. 60 people registered for both science and history. Yes and yes to both. 120 registered for history but not science. Ooh, so I guess history is just more popular. Sorry, science. 40 registered for science but not history, and 30 registered for neither. So it says the table above shows course registration for 250. Always pay attention to that if they just add it up for you. Students selected at random from a university. Assuming that the students in the sample are representative of all first-year students at the university, which of the following best estimates the probability that a first-year student who will be selected at random from the university has registered for a history course, a science course, or both during the first year? So this is an or problem, right? We'll take someone who's just history. We'll take someone who's just science. And we'll take someone who's both, and we want to know the probability of getting this over all possible outcomes. So all registrants. So interestingly enough, we already know all registrants. All registrants is, they told us 250. History only is 120, right? 120 register for history, not science. Plus, sorry, I know that's kind of tiny. Maybe I should write it over here. So this is 250. History only is 120. Science only is 40. Yes to science, but no to history. And both is 60. So what do we have? We have 220 over 250, or 22 over 25, or 88%. So D is the answer to this one. Again, not really much math involved, just your ability to understand what the question wanted and to use the chart. So let's look at one more. This one's kind of challenging. This chart tends to trip people up. And we'll zoom in to make it easy on the eyes. Okay. So Michael performed an experiment where he tossed 2 coins, 1 dime and 1 nickel, at the same time and recorded whether each one landed on heads or tails. And then his results are shown in the table below. For what percent of the tosses did the dime Michael tossed land on heads? Okay. So what we want is we're taking all tosses, total tosses of dime. And what we want is dime on heads. So let's break this down. I find it always helps to kind of write what you want over what you're over what you're choosing from. So total tosses of the dime. So if we look at it, 27 times the dime lands on heads, the nickel lands on heads. So they both land on heads. 26 times you get the dime on heads, nickel on tails. Then 24 times dime tails, nickel heads. 23 times dimes tails, nickel tails. So all in all, we've tossed this dime 100 times, right? 27 plus 23 is 50. 26 plus 24 is 50. So we've tossed this coin 100 times, and wants to know how many times did the dime land on heads. So here's heads for the dime. The dime landed on heads 27 times and 26 times. 27 times it landed on heads with the nickel, landing on heads too, and 26 times the dime landed on heads where the nickel landed on tails. So the dime lands on heads 53 out of 100 times, or 53% of the time. Okay, I hope that's helpful. Plenty more problems on this worksheet. Some involve a few more steps than what we just did, but the ability to read these charts is definitely crucial to the test. It's a big part of the data literacy push that the test makers have made. So you want to make sure that you feel comfortable with the problems on this worksheet. Good luck, and feel free to come back for any other concept work, tutorial videos and/or worksheets. Okay, bye.